a year ago, I built a Caterham with my son, and we drove it at Silverstone, really enjoyed it. And I met Tony Southgate there, and he said, look, 750 Motor Club have loads of categories for racing, and I just thought, well, it would be really good to actually design a car again and make something at the bottom, just the same as I started with my very first Formula Ford in 1973. But well, it'd be good fun to start again. I'm sort of retired now, semi-retired anyway. And I met Andre Brown, and Andre worked for me in America. He's designed and built his own Formula Student cars before, and he was invigorated with this idea. So he's done all the CAD, produced all the body shapes, done all the calculations, and I've inspired him in terms of the concept. And
this is your baby.
Yes, I mean I'm very much into low-cost manufacturability, low weights, high aerodynamic efficiencies, and obviously there's the vehicle dynamics and everything. So over the 30 years of motorsport experience, I have developed some concepts and theories which I hope are still current and valid.
Yeah, so we started that about a year ago, really the detailed design of the wind tunnel model, and we started off looking at what we could reuse from previous Reynard projects. So we wanted to always focus on keeping the cost down. Reused a lot of wind tunnel model parts, and managed to build a really low-cost model in a very short space of time. About 6 weeks it took to design and build the wind tunnel model. And we started doing some testing in February. So
I think we soon realised that this particular car could have some extremely efficient performance characteristics. During the testing, we found we were able to evolve a shape which gave very low drag but very high downforce, and at the same time we tried to find a racing formula which would allow us to drive this car. The 750 Motor Club happened to have this Bike Sports Championship which has virtually free aerodynamic rules. So having read those rules, we then developed the model to fulfill those requirements. And Andre then started to draw, and
we started that in about April, I think.
Yeah.
The detailed design of the actual car, translating the wind tunnel model shape into something that could be productionized and actually made in full scale and all work together. And I sort of liken it to trying to start a 3D jigsaw puzzle where you don't know what the end result is going to be. You don't know what picture is going to be on the jigsaw puzzle. Yet it all has to fit together in 3 dimensions. It has to function, has to look good if you're going to sell it as a road car. It has to function well as a racing car, and it's trying to marry all of those elements together in a package that doesn't weigh too much, doesn't cost too much, is easy to make.
Yeah, it had to tick a lot of boxes. It had to be very light, as Andre said. It had to be very stiff. It had to be very safe. Safety is very important for the driver, especially if I'm going to drive it. It had to fulfill the requirements of being made into a road car. So it had to follow SVA requirements, lights, crash protection, regulations for size and shape, etc. It had to be very manufacturable. So we wanted to be able to make this car in larger quantities and at a very low cost. And above all, it had to perform very competitively within the Bike Sports Championship and provide some great experiences to those who are inside it with 2 seats, that no other car could produce. So once we'd produced the high downforce and the high efficiency, this led us to be able to use very high downforce levels on the track and develop very high cornering forces. That's a lateral G about 4G, which is
it's getting up there for astronaut territory.
Yes, astronaut territory. So it's Formula One stuff. It's the sort of cornering forces that Formula One drivers will experience. So it's fairly unique in that for a car which is very low cost, very affordable and very safe, it produced these very high cornering forces.